Layer 2 is fast and cheap. You've heard that 100 times. But do you know what actually happens to your ETH when you breach it? Today, I'm walking you through an interactive site I built that answers those questions, not with text, but with simulators you can actually touch. 5 chapters, 0 jargon words. Then, let's go. Chapter 0 starts with a prediction. If fees are high, why not just make blocks bigger? Sounds obvious, right? This site lets you pick an answer before it tells you anything. I love this part. Let's pick A and C. And it says A does lower fees, but it charges you somewhere you can't see. Let's find out where with the first simulator. One caveat before we go. Ethereum hasn't frozen block size entirely. It has raised gas limits over time, and blocks are real capacity. What is avoided is the naive just make blocks huge pass. That distinction is exactly what this simulator is about. Here is a grid of nodes. Everyone verifying the chain from home computers. Now watch what happens as I drag the block size up. See them turning gray? Those are machines that can't keep up anymore. They quietly drop out. Push it to the max and only a handful of big servers remain. It's fast now, sure, but this isn't really everyone verifying anymore. That's a hidden cost. This is my favorite visualization of the trilemma. Decentralization, security, scalability, 3 sliders, 1 budget, always humming to 100%. Drag toward scalability and watch the other 2 numbers fall in real time. There's no cheat code here. Ethereum's L1 chooses to protect decentralization and security. So the question becomes, how do we get speed without touching this triangle? That's the whole idea of Layer 2. The answer, don't widen the road, build a lane above it. Transactions run up top. Only one settlement comes down to the main road. Now, the gas simulator. I'll crank congestion to maximum. L1 climbs to almost $9 per transaction. Flip the L2 switch, and it drops to about 6.5 cents. Same congestion, different bill. Because see the level. 500 transactions now share a single L1 light. Chapter 1 opens the hood. This machine shows the actual pipeline. Individual transactions come in, the sequencer orders them, and you already get instant confirmation on L2 at this point. Then they are bundled into a batch, compressed down hard, and packed into something called a blob, a 128 kilobyte data slot designed specifically for rollups. One more click and it runs on L1. Here is a part most explainers get wrong. They call it bill splitting, but splitting a $150 bill among 500 people still costs 30 cents each. The total never shrinks. A rollup is different. It writes to L1 just once and compresses the data so the whole bill gets smaller, and then that tiny bill is shared. That's why the per transaction cost drops to well under a cent, not 30. And notice the honesty here. Set it to one transaction. and the site admits there is no gain. Cheap fees didn't happen overnight. They are stacked upgrades. Core data error expensive. March 2024. Denkun blinks blocks. Fees drop an order of magnitude. Then, Fusaka in December 2025 adds peer DAS. Look at this demo. No node stores everything anymore. Each keeps a slice and they randomly ping each other. Go to a piece. Red is the question, green is the answer. Nobody holds it all, yet the data is guaranteed. Chapter 2. How does everyone know a batch is correct? 2 scores. Optimistic rollups assume it's fine and wait for objections. Let's play the game. A dishonest operator just posted a fake balance. That bar is the challenge window. About 7 days in reality. If it fails, the fraud finalizes. But anyone who notices can step in. I'll hit object. Blocked. Fraud reverted and the poster loses their bond. Now the same attack on a ZK rollup. Send the fraudulent batch. Rejected instantly. No waiting, no watchers needed. Without a valid proof, the L1 verifier contract won't even let it in. Send a valid one. It passes and finalizes on the spot. But keep one thing in mind. Optimistic security assumes at least one honest watcher exists. 0 watchers and fraud walks through. That's not a bug, it's a design's precondition. That design difference hits your wallet here. Hit withdraw both. The same moment for each. ZK arrives in hours, proof plus a safety delay. Optimistic waits the full 7-day window. But here is a twist most people miss. Switch to the liquidity bridge route. And both arrive in minutes. A provider fronts you their own money and collects later. You are not skipping the wait. You are paying someone to absorb it and trusting them. Chapter 3 is the one I most want you to see. First question, what is your L2 balance? Most people think their ETH moved to base. It didn't. Watch. The real asset gets locked in a board contract on L1. What you hold on L2 is a claim ticket. Transfers and swaps are just that ticket changing hands. And withdrawing means burning the ticket to make the vault open, which it must by code. But, and this matters, that vault model only covers assets you breached from L1. Tap through these 3. Breached ETH, the real thing sits in the L1 vault. You can always reclaim it yourself. Native USDC. There's no L1 vault. Its backing is Circle's reserves. So in an emergency, you are relying on a company, not code. An NFT minted on L2. There is simply nothing on L1 to go back to. So how much can you trust a given chain? L2 bit calls it training wheels. Stage 0, you simply trust the team. Stage 1, proofs are live. And here is the escape hatch demo. The sequencer holds, but you bypass it entirely and claim directly on the L1 contract. Fourth inclusion. After set delay, you withdraw yourself. Whether that detour exists is the line between stage 0 and stage 1. Now, the punchline of chapter 3. This matrix plots proof family against stage. And look, there are ZK rollups sitting at stage 0 and optimistic rollups at stage 1. Because a validity proof only guarantees the math was done right. If the team still holds keys that can rewrite the contract themselves, they can change the rules underneath a perfectly working proof. ZK does not mean safe. Governance decides. Chapter 4. The actual map. Building height is value secured. A veteran roughly $17 billion. Base 12. Then it falls off a cliff. With a long tail of small towers. Over 17 rollups exist. A few hold almost everything. The timeline below tells you how we got here from the 2021 launches through Tenkun to 2026, where stage 1 became the norm and the field consolidated. What's next? 2 directions. Intents. Instead of building the road yourself, pick a chain, pick a bridge, swap. You just state the wish, and a solver works it out behind the scenes. Watch it run end to end. And then based on native rollups, handing jobs back to L1. But notice this purple banner. The site is very clear. These are research proposals, not running. Don't file them next to what's live. And that's the whole journey in 5 frames. The constraint hasn't gone. Execute on L2, settle on L1. Wait for objection or attach a proof. It's the keys and the exit. A few chains and next back to L1. The site is free, runs in any browser, and speaks 5 languages. Link in the description. If you can now check what sits behind fast and cheap yourself, that's enough. See you in the next one. Bye!